Hey guys, welcome back to day 2 of notes. We're going to keep things a little bit light today. Essentially, we're just going to review some of the stuff we looked at yesterday and learn how to do it in your guys' calculator. I did want to give you guys a quick update on just some things that are going on. For example, a lot of people have been asking me in your class and other classes, hey, can you go in and get this for me? Or is there any way I can go pick this up? Or is there something at school I can grab? The answer to all of those is no. Teachers actually have been told we're not allowed in the building under any circumstance at all. So the teachers have been completely locked out as well. So if there's anything you're looking to get or anything that needs to be graded or turned in, or you need a calculator or a textbook, there's absolutely nothing I can do at this time. If that changes, I'll let you know. I know a few of you guys still need your calculator or textbook since you weren't there on Friday. So I won't be able to get that or do anything with that until they let teachers back in the building. So hopefully that will be sometime soon, and I can let you know when that happens. Second off, if you guys didn't know, they do have the meal plan happening right now. If you are a student at West High and under the age of 18, you can stop up there on Monday, Wednesday, and Friday. On Monday and Wednesday, they'll give you 2 breakfast, 2 lunch, and on Friday they only give you 1 breakfast, 1 lunch. They had that start up yesterday, but from what I hear, things ran out pretty quick. So they're working on kind of increasing the volume of items that we could possibly get and distribute. That way, that doesn't happen again. So, with that said, we can jump into what we were doing yesterday. All right. So, starting off, we were talking about geometric probability distributions yesterday. And that was when we were using what we called a Bernoulli's trial, which essentially said that there are only 2 possibilities, a success or fail. And we were using that to find pretty intense probabilities. In this case, we're doing something called a geometric distribution, which essentially is when you do a Bernoulli's trial over and over and over again until you get a first success. So that could be as small as 2 or 3 trials if you get a success early on. That could be like 150 trials if the chance of success is extremely small. So in this case, what we will be doing is going through how to do that on the calculator since we just did that in the textbook, okay? So let's go ahead and look. I'm going to bring up the little applet calculator now. When you have the calculator ready, the way we will do geometric distributions on here is by going to Menu, then you will go to Probability, all right, Probability, and to distribution. So it's menu 5 again. All right, menu probability at distributions. And we've already used a lot of these. We've used normal PDF, normal CDF, inverse norm. We've used TPDF, TCDF, inverse T. Now we will be looking more at the stuff down here. And I want you to be very careful because how mine's labeled DEFGHI, your calculators will probably not have that same menu setting. They have, for TI-Nspires, they've done a lot of updates and releases, and your calculators should be more updated than this. So a lot of you guys will actually have different menu options here because you'll have more in this full thing. So if you do have the same ones as me, great. If not, don't freak out. What we care about here is the titles, all right? So we're going to be in this chapter looking at binomial PDF, binomial CDF, geometric PDF, and geometric CDF. Those are going to be our main 4. In particular, today we are looking at geometric PDF and CDF. So we had a question that was in the textbook yesterday that talked about emails, all right? And it said that there was a 9% chance that you would get a good email. There was a 91% chance that it would be a spam email, all right? So if we wanted to do a geometric distribution to find a probability, the question asked, what's the probability that the 4th email was your first good email, all right? So if we want to do that, we would jump right back into the calculator here, and we would need to decide between geometric PDF or CDF. Now, PDF is when X is one number, where CDF is when it's a range of numbers. We're going to do examples of both of these today, but right now we are doing the one from the book yesterday, which was a geometric PDF because X was 4, which is one number. The number 4 is one number, so we had geometric PDF. Now, Looking at it, it asks for two things. It asks for P, your probability of success, and it asks for X, your value that you're using for this specific question. So for P for this, we said, what is the probability of getting a useful email? It was 9%. We always put this in as a decimal, so notice I put in 0.09, not just 9. And for X in this case, we want to know the probability that you would get the first good email on the fourth email you open. So the X in this case was 4. Now, if you remember yesterday, we had to plug it into the formula. You had to plug in for P's and Q's. You had to then figure out all right, what's the final answer from that by multiplying things together. We also saw how to do it the long way of, okay, I could do the 0.91 times 0.91 times 0.91 times 0.09 to get my answer that way. But you'll notice here, the moment I put those two things in and hit OK, it gives us the same answer that we had yesterday, all right, which is the 0.067821. So this is an extremely easy type of question to do once you have the calculator. You don't have to worry about formulas or anything like that, all right? So now what we're going to do is go ahead and look at an example of the CDF version of this, okay? So we're going to flip back to our textbook now. So it looks like in this question it says people with O negative blood are called universal donors because O negative blood can be given to anyone regardless of the recipient's blood type. Only about 6% of people have O negative blood. So the questions that we have here is, if donors line up at random for a blood drive, how many do you expect to examine before you find someone who has O negative blood? And number two, what is the probability that the first O negative donor found as one of the first 4 people in line? So again, we're looking at a question very similar to yesterday, but at the same time very different from yesterday. So the first thing I want to address is the first one. So we're looking at, let me see if I can get a pen here. All right. We are looking at this guy. If donors line up at random. So first off, why would we need all this donated blood? Because the coronavirus is getting and killing everyone. So we need O negative blood. It's an emergency. So now you got this line of people who are like, we can save the world. We got that O blood. But you don't actually know. So how many people in this line would you need to go through before you would expect to find someone that has O negative blood? So how would you go about doing this? This is an expected value question. So what did we say the formula was for expected value? Expected value was simply 1 over the probability of success. In this case, getting a probability of success, getting a success would just be getting O negative blood. So what's the probability of that happening? It is 0.06 chance. All right, so we do 1 divided by that. So you can plug that in your calculator to find out that it should be about 16.66 repeated. So what does that mean? It means that if we were to set up a line of people to try to save the world from the coronavirus with their O negative blood, we would expect to actually have to test somewhere between 16 and 17 people before we actually found one that is O negative. Does that mean it's always going to be the 16th or 17th person? No, it just means due to the whole 6% of people having it, we would expect to have to draw blood on average from 16 to 17 people before we found one that was going to have the O negative blood. The second question, what's the probability that the first O negative donor found is in the first 4 people in line, seems very similar to our question yesterday. But in this case, the key is actually this one of the first 4. Notice it doesn't say the 4th person, it says one of the first 4. So that means that when we are doing this question, this is actually going to be a CDF because our X is not equal to 4. It's actually equal to anyone in the first 4. So that could be the first person, the second person, the third person, or the 4th person. So in other words, anyone from the first person to the 4th person. All right. So let's go and look to see how we put something like that into the calculator. Okay, so we would go ahead and jump back into our menu again. This time we're going to go to 5 for probability, and we're going to go to 5 again. We're going to scroll down, and this time we're going to go into geometric CDF. The reason being is because we're looking at person 1 to 4, which means this is a range of numbers, not simply just the third person or the fifth person or whatever. So we want all the people from range 1 to 4. It pops up asking for the probability of success, a lower bound and upper bound. We have stated in this question the probability of having O negative blood is 6%, so we put in 0.06. And then for lower bound, we said anyone from the first person to the fourth person, all right? Once we plug that in and hit OK, it pops up and says the probability of that happening is 0.219251. So in other words, there is a 21.9% chance of this happening. So again, what would that mean in context of this situation? In this situation, that means that we would be looking for people with O blood. We have a line of them start up. What's the probability that the first person that has O negative blood in our line of people would either be the first person, the second person, the third person, or the fourth person? One of those four, what's the chances of that happening? So we just found out that the chance of that happening would be 21.9%. So there is a 21.9% chance that one of those first four would have O negative blood. So let's go ahead and look at what your homework is going to look like for tonight. Go to page 430 in your textbook, and you guys are going to be doing number 9, 13, and 14. All of these are geometric distribution questions. Some of them will be asking you for expected value. Other ones will be asking you to use the geometric PDF or CDF function. All right. So how are you going to turn this in? For right now, I would just say go ahead and write it down on a piece of paper. Later, since Schoology is still down, you can either we'll have you submit like a picture of what you wrote down to me on Schoology. Maybe I'll have you email a picture of it, or maybe I will have you guys type it in the Schoology. Until Schoology is fixed, I can't really tell you what the best method would be. So for right now, go ahead and just in your notebook do page 430, number 9, 13, and 14. And you guys will be turning that in the unforeseeable future because we just have no idea. With that said, guys, I hope you are staying active, staying focused. I know I had kind of put a little thing in the group text, but just remember, we could be in our homes for a very long time. And if you're sitting around and doing nothing, I promise it will set a very bad mentality or routine for you to be in for a very long time. So I would highly suggest that make a schedule, still take showers in the morning, get dressed, move around the house, maybe pick up some exercise routines if that's just going for a jog in your neighborhood, or if that's doing things more active in your house, whatever. It may not seem like, okay, you don't exercise every day on your own normally, so why would you start now? But before, even if it was just walking to and from all of your classes, getting onto the bus, getting off to the bus, if you're losing all of that and you're not making it up in any way, you are going to start building a very unhealthy lifestyle. So I hope that you guys go ahead and take this opportunity to really discipline yourself and say, hey, I need to do something. We could be on this little lockdown thing for a very, very long time. I hate saying that, and I'm not saying it to scare you. I'm just saying the reality of the situation is we need to prepare in the case that this is long term. All right. With that said, everyone have a wonderful day. I will see you guys tomorrow. Bye.